Hi, welcome to Algebra 1, Lesson 9-4, solving quadratic equations using square roots.
In this lesson, you'll be able to solve quadratic equations by taking square roots. Let's start with explore and reason. A developer is building 3 square recreation areas on a parcel of land. He has not decided what to do with the enclosed triangular area in the center. Okay, so we have square buildings that enclose the triangular area here. How can we determine the side lengths of the enclosed triangle? So before he decides what to do with this area, I think it's very important to figure out the area, right? So if he's designing something and maybe building stuff in there or designing structures in there, dimensions are very important. Otherwise, it would be very hard for the design to become real, like other people need to be able to actually construct it using the design. So how can you determine the side lengths of the enclosed triangle would be the first question that you would want to ask yourself. So yeah, in order to find this one side, right, you know you can figure out this side by taking the square root of this squared area, right? So root 576 would be this side. And then this side, the hypotenuse of the right triangle, would be root 625. And this side would be root 49. So you already know root 49 would be 7. And then you can, you can use the product property that we learned last lesson to simplify these square roots and figure out the simplified radicals. So yes, we're going to explain first what we're going to do instead of just directly solving. So practice explaining your thoughts. Take the square root of each square area. This is equal to the square's side length. And one side of each square is one of the sides of the triangle. So if we don't explain this, some people may not know why we're doing it. Like, why are we doing it? If there are people who don't understand the roots at all, right? You need to be able to explain and connect the real world scenario into the mathematical expressions and the logic behind it, right? Very important. Part B, what relationships do you notice among the areas of the squares? So the areas of the squares would be related to this area of the triangle with their sides, right? One side, each of their sides would be equivalent to each side of the triangle. So the sum of the areas of the two smaller squares is equal to the area of the largest square. Oh, this is another one, right? So 49 plus 576 is equal to 625. And this is, again, Pythagorean theorem. Yeah, because, you will learn this later. But Pythagorean theorem basically says if there's a right triangle, one side square, so a square plus b square is equal to c square. One side square plus another side square is equal to the hypotenuse square. So part C, how can the developer adjust this plan so that each recreation area covers less area, but still has a similar triangular section in the middle? How could we adjust this, right? Yeah, so maybe if you move the squares, maybe it would be different, but the sides are gonna be the same. So if you're gonna enclose this triangular area with all these squares, then the area has to be the same. Yeah, but if we adjust the areas of the square, like if we make them smaller or bigger, then the area of course would be similar. Triangular section, like the ratios would be the same if we divide by the same ratios, right? So if we say, oh, I'm gonna cut this in half, I'm gonna cut that in half, I'm gonna cut that in half, so then we may have areas that look like this, but then it's smaller, right? It's smaller, but then it's still similar. So if we divide by the same numbers, of course, then the ratios will be the same, so the triangle will be similar. Okay, so in geometry later, you'll learn that similar triangles may not have the same sides, but their ratios are the same of the sides of the angles are are equivalent to each other, but the sides are have the same ratio. So we can explain that triangles are similar as long as their angles are congruent and their corresponding sides are in proportion. So multiplying each side by 1/2 would create a triangle that is similar and cover less area than the original triangle. Okay. So these are some questions to think about. It may be hard to understand everything in this example because, yeah, we haven't learned geometry yet, at least in ISQ. So, yeah, it may come to you later. But this is a great example to know why we need to know square roots and why do we need to know how to how to solve quadratic equations using square roots. Okay, so the essential question for this lesson is how can square roots be used to solve quadratic equations? So let's look at an example. We're going to solve equations of the form x squared equals a. So x squared is already isolated here, right? What if we have x squared is equal to 49? Then we're going to square both sides and say, oh, if x squared is 49, 7 squared is 49, so x must be 7, right? So then we have 7. But because it's squared, we can also have -7 squared, right? -7 squared would also be positive 49. So then for roots, you may have two different solutions when you have square roots or even number roots. So remember that even number square roots will have plus or minus two different solutions. What are the solutions of the equation x squared is equal to -121? So now we know that square root is the inverse operation of squares. So we can root both sides, but then negative radicand is impossible, right? So this is not a real number. It is going to be an imaginary number. And we're going to learn that later. And there is a way to represent this and solve it. But we're not going to talk about imaginary numbers right now. So you can just say there's no real number that could be multiplied by itself twice to get a negative number. That's just not possible. Okay, it's just not logical in our mathematical sense. So this is no real solution. So let's look at try number 1. Solve each equation by inspection. Inspection just means observing, looking at it, thinking about it. So then you may have no real solution. So think about that when your x is isolated and you want to root them. Think about if it's negative, because if it's negative, then it's no real solution because your radicand would be negative, and that's not possible. So pause the video, see if you can solve this by yourself. You may have already have an answer, but come back when you're ready for answers. Okay, are you ready? So part A, you have x squared is equal to 169, and this is also a perfect square. X is equal to plus or minus root 169, which is equal to plus or minus 13. So x is equal to plus or minus 13. Part B, x is equal to root plus or minus negative 16, but negative cannot be a radicand, so this is no real solution. Okay, good. That was example 1. Pretty simple, right? Let's go to the next page, example 2. Solve equations of the form ax squared equals c. What are the solutions of the equation 7x squared is equal to 1112, right? So now if we have an equation where x is not isolated, our first goal is to isolate the variable. So in order to get rid of 7 is multiplied by x squared. So the inverse operation of that would be division. Divide by 7 on both sides. You will have 1x squared, which is x squared, and 112 divided by 7 is 16. So square root both sides, you will get plus or minus 4. And then same thing here, you can divide both sides by negative 3, and then have x squared is equal to 8. And so your final solution would be plus or minus root 8. This is already a simplified form, and so that is your answer. So let's look at try number 2. What are the solutions for each equation? You have to isolate the variable, and if it's not a perfect square, state what two integers the solution is between. So yeah, if it's like root plus or minus root 8, you can say, oh, it's between root 9 and root 4, which are perfect squares. So it should be between the two integers 2 and 3, right? So this would be between 2 and 3. So negative 2 and 3 as well. Okay, so pause the video, see if you can solve these two by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. So isolate the variable. You will have x squared is equal to 125 divided by 5, which is equal to 25. And so x squared is equal to 25. X is equal to plus or minus root 25, which is equal to plus or minus 5. Okay, part B, you're going to multiply by negative 2 on both sides, and you have x squared is equal to positive 72, right? And so if you square root both sides, you get plus or minus root 72. And if you factor 72 out with the prime numbers, you would have 2 times 2 times 2 times 3 times 3. So then you can take these out. 2 times 3 is 6. So plus or minus 6 root 2 would be your final solution. And what two integers would the solution is between if it's not a perfect square? So this would be root 72 is between which two perfect integers? To perfect squares. So root 81 is the greater one, greater than 72. So And then let's see. So that's 9. What's 8 squared? 64. So root 72 is greater than 64, less than root 81. So then it's greater than 8, less than 9. So we can say it's going to be between 8 and 9, or negative 8 and negative 9 if it's a negative 6 root 2. Okay, so check your answers, see if you got it right. If you did, good job. We can move to the next example. It's a conceptual understanding example. We're going to solve equations of the form ax squared plus b equals c. So how can you solve the quadratic equation 3x squared minus 5 equals 22? We have more steps now, but that's okay. You already know how to isolate your variable, right? So you do step by step, inverse operation. The order is also flipped. So you add 5 on both sides first, right? And then you have 27 on the other side. 3x squared equals 27. And then you divide 3 on both sides. You have x squared is equal to 9. Square root both sides, and you have plus or minus 3. So, yeah, it's basically the same as example 1 and 2, but you have more steps. Use the properties of equations. So solve the quadratic equations and try number 3. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. So you're going to add 19 on both sides first, right? And then you have negative 5x squared equals 163. And then you divide 163 by negative 5, and you'll get negative 32.6. Yeah. And so, and if you root both sides, square root both sides, you have a negative radicand. So this is no real solution. Okay, part B. Subtract 17 on both sides. And then you'll have 3x squared equals 192. And then divide by 3. You'll get 64. Root both sides, and you have plus or minus root 64, which is a perfect square, and that's equal to plus or minus 8. Okay, that was example 3. So these are the skills that you need for solving equations with square roots. Let's look at application problem in example 4. Determine a reasonable solution. So a cell phone tower here has a guide wire for support as shown here. The height of the tower and the distance from the tower. So height of the tower, distance from the tower to where the guide wire is secured on the ground are the same distance. So this and that same distance. So it's a triangle, right triangle with same side lengths, right? The legs. And then the hypotenuse, we don't know. But we can figure it out if we have enough information. But here we have the information, right? Guide wire is 200 feet long. What's the height of the tower? So we want to figure out the height of the tower, which is the same from the distance from the tower to where the guide wire is secured on the ground. So yeah, if you know the Pythagorean theorem, it's a squared plus b squared. A, if that's a and that's b and that's c, Pythagorean theorem again states that a squared plus b squared is equal to c squared, because if that's a square, that's a square. You add the areas of the square together, it's going to be the same as the area of the square here. Yes, so if it's a right triangle, this always works. So that means we can write an equation, set up an equation where x squared plus x squared, which is the same, right, is equal to 200 squared. right? So write that equation, set up the equation, and then you can solve for x because that would be your height of the tower. So these are like terms. You can have 2x squared is equal to 200 squared, which is 40,000, and then divide 2 on both sides, square both sides, and then factor them out so that you can square root easily. Square root 100 is 10. So 10 times 10 is 100, and you have root 2. So it's plus or minus 100 root 2. It's not a perfect square, but you can leave it like that. So height of the tower cannot be negative, right? So you can opt out the negative solution and say the solution must be 100 root 2, which is about 141. So it's approximately 141 feet. Okay, so in real world situations, a lot of times you are going to leave out the negative solution because in a lot of examples in real world, negative might not make sense in that case. Let's look at try number 4. We have the same kind of situation, but we want to find the distance from the base of the tower to the midpoint of the guy wire. You need to think a little bit. So pause the video, see if you can figure this out, and come back when you're ready for answers. Okay, are you ready? Okay, so now we have a new triangle, right? So then if this is the right triangle, your hypotenuse here is x, which we already figured out is going to be 100 square 2. And this part is 100 feet long, right? So we already know that if you've learned geometry, you would know if this is a midpoint and these sides are the same and these sides are the same and the angles are the same by SAS theorem. The triangles are similar. The triangles are congruent. So when their triangles are congruent, we can say that the sides are, the sides are also the same. The corresponding sides are the same. So the corresponding sides, would be 100 feet. So Z has to be 100 feet as well. But we can double check, right? If you don't know, if you haven't learned geometry, you have to use algebra, right? So 100 algebra as much as you can, right? 100 feet squared, this is a leg, and that's a new leg, plus z squared is equal to 100 root 2 square. And so you're just gonna check if z is truly 100 feet, right? Which is going to be, but let's check, okay? Double check. So isolate your z. You have 100 square root 2 square, which is 10,000 times 2, so 20,000, minus 100 square, which is 10,000, which is equal to z squared. So that's going to be 10,000 equal to z squared. And if you root it, you have plus or minus root 100 times 100, right? So then that's really equal to plus or minus 100. And the negative distance doesn't work. So 100 feet is what you're looking for. So that's 100 feet as well. Okay, so let's look at the concept summary. To summarize our lesson, we learned how to solve quadratic equations using square roots. In order to solve equations that has quadratics and you can use square roots. First, you need to isolate the variable. First step, and then you take the square root of both sides, and then you'll be able to figure it out. But remember, when you have a negative radicand, that is a no solution. Okay, so that was lesson 9-4 in Algebra 1, solving quadratic equations using square roots. We will continue with the next lesson in the next video. Bye!